Welcome back. In the last video, we set up some device agnostic code. So this is going to come in later on when we send our model to the target device and also our data to the target device. This is an important step because that way, if someone else were to run your code or you were to run your code in the future, because we've set it up to be device agnostic, by default, it will run on the CPU. But if there's an accelerator present, well, that means that it might go faster because it's using a GPU rather than just using a CPU. So we're up to step 2 here, construct a model by subclassing NN module. I think we're going to write a little bit of text here just to plan out the steps that we're doing. Now we've set up device agnostic code. Let's create a model so we're going to break it down. We've got some sub steps up here, but we're going to break it down, even this one down into some sub steps. So number 1 is we're going to subclass NN.module. And a reminder here, I want to make some space just so we're coding in about the middle of the page. So almost all models in PyTorch subclass NN.module because there's some great things that it does for us behind the scenes. And step 2 is we're going to create 2 NN.linear layers. And we want these that are capable to handle our data. So that are capable of handling the shapes of our data. Step 3, we want to defines a forward method. Why do we want to define a forward method? Well, because we're subclassing NN.module, right? And so the forward method defines a forward method that outlines the forward pass or forward computation of the model. And number 4, we want to instantiate, well, this doesn't really have to be the part of creating it, but we're going to do it anyway. Instantiate an instance of our model class and send it to the target device. So going to be a couple of little different steps here, but nothing too dramatic that we haven't really covered before. So let's go number 1, construct a model that subclasses NN.module. So I'm going to code this all out. Well, we're going to code this all out together, and then we'll go back through and discuss it, and then maybe draw a few pictures or something to check out what's actually happening. So circle model V1, because we're going to try and split some circles. Red and blue circles. This is our data up here. This is why it's called circle model, because we're trying to separate the blue and red circle using a neural network. So we've subclassed NN.module, and when we create a class in Python, we'll create a constructor here, init, and then put in super._init. And then inside the constructor, we're going to create our layers. So this is number 2, create 2 NN linear layers capable of handling the shapes of our data. So I'm going to write this down here. 2, create 2 NN.linear layers capable of handling the shapes of our data. And so if we have a look at xtrain, what are the shapes here? What's the input shape? Because xtrain is our features, right? And our features are going to go into our model. So we have 800 training samples. This is the first number here, of size 2 each. So 800 of these, and inside each is 2 numbers. Again, depending on the data set you're working with, your features may be 100 in length, a vector of 100, or it may be a different size tensor altogether, or there may be millions. It really depends on what data set you're working with. Because we're working with a simple data set, we're going to focus on that, but the principle's still the same. You need to define a neural network layer that is capable of handling your input features. So we're going to make layer 1 equals NN.linear. And then if we wanted to find out what's going on in NN.linear, we could run Shift Command space on my computer because it's a Mac, maybe Shift Control space if you're on Windows. So we're going to define the in features. What would in features be here? Well, we just decided that our X has 2 features, so our in features is going to be 2. And now what is the out features? This one is a little bit tricky. So in our case, we could have out features equal to 1 if we wanted to just pass a single linear layer, but we want to create 2 linear layers here. So why would out features be 1? Well, that's because if we have a look at the first sample of yTrain, we would want us to input, or maybe we'll look at the first 5. We want to map one sample of x to one sample of y, and y has a shape of 1. Or well, really it's nothing because it's a scalar, but we would still put 1 here so that it outputs just one number. But we're going to change this up. We're going to put it into 5, and we're going to create a second layer. Now, this is an important point of joining together neural networks. In features here, what do you think the in features of our second layer is going to be? If we've produced an out feature of 5 here, now this number is arbitrary. We could do 128, we could do 256. Generally, it's multiples of 8, 64. We're just doing 5 now because we're keeping it nice and simple. We could do 8. Multiples of 8 is because of the efficiency of computing. I don't know enough about computer hardware to know exactly why that's the case, but that's just a rule of thumb in machine learning. So the in features here has to match up with the out features of a previous layer. Otherwise, we'll get shape mismatch errors. And so let's go here, out features. So we're going to treat this as the output layer. So this is the out features equals 1. So takes in 2 features and upscales to 5 features. So 5 numbers. So what this does, what this layer is going to do, is take in these 2 numbers of x, perform an n.linear. Let's have a look at what equation it does. An n.linear is going to perform this function here on the inputs. And it's going to upscale it to 5 features. Now, why would we do that? Well, the rule of thumb here, because this is denoted as a hidden unit, or how many hidden neurons there are, the rule of thumb is that the more hidden features there are, the more opportunity our model has to learn patterns in the data. So to begin with, it only has 2 numbers to learn patterns on, but if we upscale it to 5, it has 5 numbers to learn patterns on. Now, you might think, why don't we just go straight to like 10,000 or something? But there is like an upper limit here to sort of where the benefits start to trail off. We're just using 5 because it keeps it nice and simple. And then the in features of the next layer is 5 so that these 2 line up. We're going to map this out visually in a moment, but let's keep coding. We've got in features 2 for x, and now this is the output layer. So takes in 5 features from previous layer and outputs a single feature. And now this is same shape as y. So what is our next step? We want to define a forward method, a forward computation, a forward pass. So the forward method is going to define the forward computation, and as an input, it's going to take x, which is some form of data. And now here's where we can use layer 1 and layer 2. So now let's just go return, or we'll put a note here of what we're doing. 3, we're going to go define a forward method that outlines the forward pass. So forward, and we're going to return, and here's some notation we haven't quite seen yet. And then we're going to go self layer 2, and inside the brackets we'll have self layer 1. Inside those brackets we're going to have x. So the way this goes is x goes into layer 1, and then the output of layer 1 goes into layer 2. So whatever data we have, so our training data, xtrain, goes into layer 1, performs the linear calculation here, and then it goes into layer 2, and then layer 2 is going to go to the output. So x is the input, layer 1, computation, layer 2, output. So we've done that. Now let's do step 4, which is instantiate an instance of our model class and send it to the target device. So this is our model class, circle model v0. We're just going to create a model because it's the first model we've created of this section. Let's call it model 0, and we're going to go circle model v1, and then we're going to go .2, and we're going to pass in device because that's our target device. Let's now have a look at model 0, and then, oh, typo? Yep, classic. what did we get wrong here? Oh, did we not pass in self? Self, oh, there we go. Little typo, classic. But the beautiful thing about creating a class here is that we could put this into a Python file, such as model.py, and then we wouldn't necessarily have to rewrite this all the time. We could just call it. And so let's just check what device it's on. So target device is CUDA because we've got a GPU. Thank you, Google Colab. And then if we wanted to, let's go next model 0.parameters. We'll call the parameters and then we'll go device. CUDA. Beautiful. So that means our model's parameters are on the CUDA device. Now, we've covered enough code in here for this video. So if you want to understand it a little bit more, go back through it. But we're going to come back in the next video and make it a little bit more visual. So I'll see you there.